Next problem, the Fourier transform of f of x, where f of x is equal to x, x less than or equal to a, 0, x mod x is greater than a. Fourier transform of f of x from the definition f bar of p, which is equal to 1 by root of 2 pi integral minus infinite to plus infinite e power I px f of x dx. That is the equation number 1. Given f of x is equal to x mod x is less than or equal to a, 0 mod x is greater than a. That is equal to f of x is equal to x if x lies between minus a to plus a and 0 otherwise. That is equation number 2. We are going to use 2 in 1. In 2 we are having two intervals. One is x is lies between minus a to plus a, and other one is other than this interval. That means from minus infinite to plus infinite we have to split the interval into 3. So first minus infinite to minus a, then minus a to plus a, then a to infinite. So we are splitting 1 into 3, that is 1 by root 2 pi integral minus infinite to minus a e power I px f of x dx plus 1 by root 2 pi integral minus a to plus a e power I px f of x dx plus 1 by root 2 pi integral a to infinite e power I px f of x dx. 3. Now we are going to use 2 in 3. So first one 1 by root 2 pi integral minus infinite to minus a e power I px. In that interval value of f of x is 0 into dx plus 1 by root 2 pi integral minus a to plus a e power I px. In this f of x is x dx plus 1 by root 2 pi integral a to infinite e power I px. In this interval f of x is 0 dx. Therefore f bar of p, which is equal to, so first and third integral become 0. So we will get only second 1 by root 2 pi integral minus a to plus a e power I px x dx. Right? Now we are going to evaluate this integral using Bernoulli's formula. Right? Integral u dv, which is equal to uv minus u dash v1 plus etc. etc. We know u dash, u double dash are successive differentiation of u, and v1 etc. are successive integrals of dv. Right? So here u is equal to x, dv is equal to e power I px dx. U dash, that is du dx, that is 1, and v, that is integral dv, that is integral e power I px dx, that is equal to e power I px by ip. Next v1 equal to integral v dx, that is equal to 1 by ip e power I px dx. So integral 1 by ip integral e power I px is nothing but 1 by ip e power I px by ip, that is equal to 1 by I square 1 by p square e power I px. So minus 1 by p square e power I px. Now f bar of p, which is equal to 1 by root of 2 pi integral minus a to plus e power I px x dx, which is equal to, using Bernoulli's formula, 1 by root 2 pi. So first one uv x into e power I px by ip, lower limit minus a, upper limit plus a, minus u dash v1 1 into minus 1 by p square e power I px, lower limit minus a, upper limit a. Substituting lower and upper limit. Before that we are arranging the brackets. So x e power I px by ip minus a to plus a. So taking that minus outside, minus into minus plus 1 by p square e power I px minus a to plus a. Now applying the upper and lower limit, 1 by root 2 pi. So upper limit a e power I pa by ip minus a e power ip minus a by ip plus 1 by p square e power ipa minus 1 by p square e power ip minus a. So 1 by root 2 pi a by ip e power ipa plus e power minus ipa. Second term plus 1 by p square common term, so take it outside, e power ipa minus e power minus ipa. We know e power ip plus e power minus ip is equal to 2 cos p, and e power ip minus e power minus ip, which is equal to 2i sin p. We are using this formula in above. So we will get 1 by root 2 pi a by ip 2 cos pa plus 1 by p square 2i sin pa. So taking 2 outside, 2 by root 2 pi, so multiplying I in numerator, I in denominator, we will get ai by I into I square p cos pa plus 1 by I by, so right, taking I outside, I by p square sin pa. So that is equal to taking I outside 2I by, in denominator, common denominator, we are taking common denominator p square, that is also there, 2I by p square root of 2 pi, remaining term I square is minus 1, so minus, so in denominator you are having p, so you have to multiply p in the numerator when you are taking the LCM as p square, right, minus ap cos pa plus sin pa. So f bar of p, which is equal to root 2 by I, because 2 root 2 get cancelled, so root 2 in numerator, root 2 I by p square root pi sin pa minus ap cos pa. Thanks.